Kubernetes, where we have to utilize Kubernetes in configuring one of the environments. So I am more of looking into. I know some of the concepts of Docker, how the image will be, and how Docker desktop will work, and how we can use one of the existing images and all. Until that point, I am clear. I am more on in on get to know how it is end to end. Basically, that's it.
Okay, fine. So another one. So your expectation, you have an knowledge about the Docker and you are trying to learn about the Kubernetes and the basic knowledge. I can call it as a basic knowledge about the Docker. Okay.
Correct, correct.
Kubernetes, you want to get a complete knowledge on Kubernetes and you are working as a developer.
Correct.
So which developer, are you a Java or else which is the domain you are working with?
MuleSoft it is.
MuleSoft. Okay.
Yeah.
So that's fine. So you are a developer and what we are going to discuss in the Kubernetes. So that will be very helpful for the developers who are building the
Correct.
images and who are working around the applications. That will be very helpful. We'll discuss about that
Correct.
when we are going into the concepts. Yes. So I'm expecting
Okay.
further from the other guys. Yes. Any another person? Can you please share your expectations towards this Docker and Kubernetes? Okay. So no issues. We have got one answer. That's fine. So slowly we will go with the another people to give me the answers. The point is, my training sessions won't be like the every training sessions like only one way of communication won't be there. So I want the both way of communication, and I want you to act smart and you have to deliver smart. Like you have to, whenever there is a question for you, at least if you say the wrong answer, I don't mind, but at least I just want you to open the mouths and tell me the answers. That's it. So if it is a bit harsh, but that's okay, no problem. So, but the point is, I want each and every guy to be answerable for the question, or else at least if you don't understand, if you can say that I did not understand, then I can repeat it back to you again. Okay, fine. Now let us get back to the main concept of your expectations. See here, we are going to learn about the complete Docker related configurations. So in Docker, what you are going to learn? The first one is Docker basics, where you are going to learn about the containerization platform or else Docker architecture and Docker lifecycle. Simply, we will call it as a container lifecycle. Container lifecycle. That is what you are going to learn in the Docker basics. Okay. And the second one will be, after learning the Docker basics, we will be going with the Docker network. We are going to work with the Docker network, and in the Docker basics, what you are going to learn here is Docker installation also will come under the Docker basics. Okay. And the next one is Docker networking. So what are the different types of networks that you are having? Bridge network and the external network that you are going to learn about that. Bridge and external network. And there are somewhere around, there are so many other networks. Okay, so that is what Docker networking, all of like overlay network is also available. Okay, you will learn about these things. And the next one is, so this overlay network is especially in the Docker Swarm you will get. In the Docker Swarm you will get this knowledge about the overlay network. And the next one is containers, basics of containers, container creation, So in the basics of container creation, you will learn about what is meant by container, what is a container, and then you will be working around image creation, Docker images, how you have to create the images. So here you will get the instructions used in Docker images. What are the different types of instructions that we have to use in the Docker images? And the fifth one will be then you are going to learn about Docker volumes. Okay, what is meant by Docker volume and how we are going to work around with the Docker volumes. And the next one is Docker. What else we have? Docker Compose, and the seventh one will be Docker Swarm. So these are the concepts that we are going to cover in the Docker. So only 7 concepts. Yes, there are 7 concepts, but it will take more than 10 days to complete the Docker in deep. Okay. So on the next one, we are going to work around with the Kubernetes. So what is Kubernetes and how we are going to work around with the Kubernetes? First one is introduction to K8s, nothing but Kubernetes. And then we are going to learn about, in the introduction itself, we are going to learn architecture of Kubernetes, microservices and monolithic services and microservices that we are going to get. What are the difference between monolithic and microservices? Monolithic application and microservice architecture. And next one we are going to discuss about and next one we are going to discuss about Kubernetes architecture, K8s architecture. So these are the concepts that we are going to discuss in the first one, and then installing Kubernetes cluster with kubeadmin, kops, rancher. These are the different tools that we are going to work with. Rancher. So here we are not going to work with the Minikube. If at all, if you are having any expectations that we are going to work with the Minikube, remove that. We are not going to work on the development namespace or else development space. We are going to work in the production production spaces. So in production, how the cluster will be created and how we are going to work around with the cluster. Okay. So that's about the Kubernetes cluster with the kubeadmin, kops and rancher. And there is K3s also, which is a very small tool. If time is there, we will cover the K3s also. And later we will go with the, so after installing Kubernetes, we will be working around with the primary components of Kubernetes. Components of Kubernetes. What are those? Those are called as pods, replica set, deployment, stateful sets, and then daemon set. These concepts we will be working around, and later we will go with the services. In services, we will cover cluster IP, node port, and then we will be going with the load balancer service and external IP. External IP. These are the different services which we are going to work around with the Kubernetes. And the next one we will be talking about the ingress controller. Ingress controller, Nginx ingress controller, and the sixth one will be probes. Okay, in probes you will have readiness probe, startup probe, readiness probe, and then you will have live probe, liveliness probe. Okay, these are the different types of probes that we are going to work around. So, and later we are going with the next concept of what I can say. After probes, you will be going with the namespaces and resource quotas. And later we will work with the Kubernetes advanced scheduling. Kubernetes advanced scheduling. In Kubernetes advanced scheduling, we will work with the node selector. There are options called as node selector, node affinity, and then pod affinity, pod anti-affinity, and then we will go with the taints and tolerations. So these are the concepts that we will cover in the Kubernetes advanced scheduling. Okay, and later uh, after Kubernetes advanced scheduling, we will discuss about RBAC rules, role-based access control. So here we will discuss about roles, role bindings, and then we will go across with cluster roles and cluster role bindings. Cluster roles and cluster role bindings. Okay, and after RBAC, we will be discussing about storage. In storage, we will be discussing with the empty directory, nothing but ephemeral storage. And the next one is persistent volumes, persistent volume claims, and EBS volume. Okay, and the next one is configuring EFS with the Kubernetes. These are the concepts that we are going to cover. And the 11th one will be after storage. We are going to work around with the monitoring tools, monitoring Kubernetes monitoring K8s with the help of Prometheus and Prometheus and Grafana dashboards. And later we will work with the next one. What is that? Cube metric server. Cube metric server. Okay. And later after monitoring, we will be working around with the logging concepts. Logging. So where you are going to learn about EFK. Okay, so this is called as, or else you can go with ELK stack also. ELK, Elasticsearch, you will learn about Elasticsearch, and then FluentD, and then FluentD, and then Kibana. These are the concepts that we are going to work around. And the next one, we are going to discuss about Helm charts and STO mesh, STO service mesh. This concept we will be discussing, and the next one will be creating, if possible, no, up to here we can go, or else we can go with the managed. This is the optional one. Don't get managed EKS services with AWS. So I cannot give you assurance with that, but these are the concepts that we are going to cover in the entire Docker and Kubernetes. Look at that. There are 7 concepts in the Docker and somewhere around 13 to 14 concepts in the Kubernetes. So just you can skip this managed EKS services. So it's a simple concept. So these are the things that we are going to work around in the entire Kubernetes. Okay, so what are the prerequisites to learn the Kubernetes? First one is Docker and Kubernetes. First one, you need to have an AWS account. So why? Because everything whichever we are covering in the Docker and Kubernetes, we will be creating the resources in the AWS. So the mandate thing is AWS account. And then what we will be seeing here is second prerequisite will be you need to have a GoDaddy domain name. Purchase a GoDaddy domain, and that will be somewhere around 220 rupees. You can get the GoDaddy domain and you can integrate that with your AWS account. Okay, this is the second thing. And the third thing is a laptop with good internet connection. And you don't require 8 GB, 16 GB of RAM if you are having one CPU or like Intel i5 processor i5, i3, any. Nowadays, every laptop is coming with i5 processor only. If you are having i3 also, it is okay. 4 GB of RAM is more than enough. If you are having the laptop with that, you can go, you can do the practicals. So every session is a practical oriented session. Mostly you will have the practicals. With the practical only, I am going to tell you the entire concepts. So that's about the syllabus of entire Kubernetes and Docker. Don't get frightened about by seeing the syllabus. These are very, very, very simple concepts. Yeah, so that's about the syllabus. Now, if you have any questions, you can ask me now. Regarding the syllabus, you can ask me the questions. Anyone to start with? You can start your questions. So any question, I don't mind, sir. I don't know what is AWS. So how you are going to deal with that? So any question is fine for me, but I want you to respond. Guys, we don't have all day. Any questions you have, say at least say yes or no. We don't have any questions. If you have yes, ask the questions.
Hello, sir. Am I audible?
Let's tell me.
Yeah, can we have notes for the syllabus?
Notes?
Huh?
What kind of notes you are expecting? I did not get that.
Any description about the practical that you are telling? Like,
That
because
you
I
will
am new
get.
to this.
Yeah, I
Uh,
understand. That you will get when you attend the sessions. Okay.
okay.
The syllabus is just what you are going to learn. Okay. So, but once you go into the concept, then only you will understand. But it is very simple for you to learn the concepts. I'm not saying that it will be very tough for you. So notes for the syllabus, if you want, you can search anywhere, you can get the notes. It's not a very difficult task. Anywhere in the sense, see, if I go with the Docker, so you can
Mhm.
search in the chat GPT also, just give me the basic like content. It will provide you the entire content also. Okay. So if you don't understand, that's fine. So the point is, syllabus is just for make you comfort what you are trying to learn. So don't get frightened. So even when I am starting my learning towards the Docker and Kubernetes, by looking into the syllabus, I was very frightened. So what they are saying. So, but the point is, once you get into the concepts, it will be very easy for you. Okay, so it's just a simple practical how we are going to work around. Okay, it's not a very big theory for you. Okay,
Okay, sir. Thank you.
yeah. Any questions? Okay, so this is about your Kubernetes, entire Docker and Kubernetes concepts. So what you are trying to learn in the next sessions, we will see. So the next one is after this prerequisites, let us discuss about a small description about what will be there before, what is there before, and what is there now. So previously what we used to have, now what we are having in the IT industry. So if you see here in the IT industry, when we are working now, we are hearing a lot and lots of words called as Docker, container, Kubernetes, and OpenShift. Like these terms you are hearing now. But if you go somewhere around some 10 years back or else some 15 years back, at that time we don't have this Docker and Kubernetes. Of course they are there, but we rarely habituated for that. Okay, so now the point is, what I want to say you here is, so how this Docker and Kubernetes has changed the entire world. See, whenever we are discussing about the Docker and Kubernetes, what we used to have previously there are on-premises servers. So where are these on-premises servers are available? So we are saying that on-premises servers. So where these on-premises servers are available? So these on-premises servers are there in a data center. Inside the data center, there will be a very big data center where you are having so many number of racks, and inside the racks you are having so many number of servers. Now inside this data center you will be having the servers, and this servers will have an operating system. Whatever the servers that we are discussing, these servers will have an operating system. This operating system will work around, okay, so whatever the operating system that you are seeing here, inside this operating system we are going to create the applications. Now there is a server, there is a physical server. This physical server is of some 16 CPU and somewhere around some 512 GB of RAM is there. Some 16 CPU, 512 GB of RAM is there for this server. Now this 512 GB of RAM is more than enough. It's a huge amount of RAM space which is not required for a single operating system or a single application. So there is a problem with this, what I can say, there is a problem with this huge amount of server, okay, huge amount of resources. So why the entire resource utilization is not happening by the application. Now if I want to create another application, this server is not supported. The server is not supported. Why? Because for example, if you are running a Java related application, I am running a Java 8 related application. Now you developed a Java 17 related application. Now in this server, there is Java 8 related application is running. Suddenly you are trying to install Java 17 related application. The server will not accept that. The server will not accept this application which is created on Java 17. So even though you are having huge amount of space here, even though you are having huge amount of resources in the server, but still the server don't react as you are expected. Okay, so for that what happened, the IT had changed and there is a new revolution was introduced into the IT world, and that is called as VM, nothing but virtual machines. Virtual machines. So what are these virtual machines? If you are having if there is a very big logical, or if there is a very big physical server is there, okay, like I said you, physical server, if there is physical server like this manner, 16 CPU and 512 GB of RAM server is there, this server we are going to divide it into small logical machines. Logical machines are going to be created, and these logical machines are called as, whatever the logical machines that we are creating, these logical machines are called as virtual machines. Whatever the logical machines that you are seeing here, these are called as virtual machines. So from where the virtual machines are going to take the, from where the virtual machines will be taking the resources from the physical machine. Sir, I am unable to understand. Let me show you one thing. Look at here, there is a, if you see my task manager, hold on. Look at the task manager. If you see my RAM, I mean my system RAM and processor, there is an it's an i5 processor with 3 gigahertz of processing speed is there, and 32 GB of RAM is there. Okay, so now if you see, this is my physical server. Whatever I am trying, I am giving you the training. This is my physical server. In this physical server, I install a virtualization software. So now what I can do, I am trying to run certain application. So now if you see here, this is my Windows operating system. Whatever you are seeing here, this is my Windows operating system. Now I am trying to create a Ubuntu mission. Whatever this master mission that you are seeing here, this is a Ubuntu mission. Okay, let me power on this. So if you see in the Windows, I am able to create a logical mission. When this logical mission is getting started, here you can see my 12 GB of RAM, or else my 32 GB of RAM is slowly increasing from somewhere around 11 GB to 12.5 GB when the system is getting started. Now see here. And if I turn on the another system in my same Windows operating system, I am trying to turn on the second virtual mission also. So this is also another virtual mission. So now these virtual missions are consuming my memory. Here you can see the CPU utilization has been slowly increased, and as well as the memory utilization is also getting increased. Okay, so now this is how my servers or else whatever the virtual missions that I have created, these are working. So what is a virtual mission? A virtual mission is also a logical operating system. A virtual mission is also a logical operating system, or else logical mission. Okay, it's an imaginary computer in which we are going to install the operating system, and we will be running the operating system. In a single physical mission, you can have multiple number of virtual missions. If you can see here, right now I am having a server. Okay, so this is my server on which I am giving you the classes. So inside this server, I install a virtualization platform, and then I have created some virtual missions. So this is virtual mission 1 and virtual mission 2, like that. So what is my server capacity? My server capacity is like i5 processor with somewhere around 32 GB of RAM. So now these virtual missions are going to consume the resources from this physical resources. So and work accordingly. So same as it is, they will be working. The virtual missions are also going to be working like the same physical missions. Now if you see here, I can log on to this servers. So there is server 1 and server 2. So I can log on to the servers. Already Kubernetes cluster is created inside this servers. So offline Kubernetes cluster is created. So what I want to show you, so this entire CPU will not be misutilized. If you are going with the virtualization platform, so the IT industry has started the virtualization platform. So the resource utilization will be optimized. Whatever the resource utilization that you are having, those will be optimized. Here, my RAM consumption has been increased to 15 GB. Okay, so previously it used to be 12 GB. Now it has been increased to 15 GB. Why? Because the virtual missions are consuming the resources. Due to that reason, the physical resources are getting captured. Okay. So now the point is, so these virtual missions are there. That's fine. Now why we are going with the containers? What is the necessity of going with the containers? So now we have to discuss about that. So what is meant by a container and why we are going with the containers? So whatever the physical missions that you are seeing and whatever the virtual missions that you are seeing, they are heavy weighted. What is meant by heavy weighted? Which means that, so if you want to take a snapshot, you can take the snapshot of this entire virtual mission, and then you can save it. Once you have saved the snapshot of this virtual mission, you can take the snapshot into another virtual mission also. But the main point here, what you need to understand is, if I want to zip this virtual mission, and or also here you can do the managing, and you can zip the entire virtual disk. Whatever the virtual mission that you are having, you can zip that. So once you have zipped that virtual mission, now what is going to happen? So that virtual mission, if you want to carry from one location to the another location, it is going to take lots and lots of time and lots of space even though. So this is the main drawback of the virtual mission. It's a heavy weighted. So for example, an application I have developed in the development environment. So you know that in the IT world, there will be development environment and testing environment and production environment, or else I can call it as UAT environment. So testing also known as, I will call it as UAT environment, user acceptance testing. So if you create an application and that is successfully worked in the development environment and you want to migrate it to the UAT environment, so normally it is very difficult task to migrate the application from development environment to the UAT environment. So to overcome this challenge, what I can do, I can go ahead with the containerization. So containerization is a platform where you will have lightweighted images that can be transferred from one environment to the another environment. So not only that, we will be using so many different concepts of containers and how containers will be working and what exactly is a container. We'll discuss about these things in the next upcoming sessions, and what is meant by virtualization. How many types of virtualization are there? Now, whatever the virtualization that you have seen in my system, this is called as hosted virtualization. In general, in AWS or else in Azure or else in any cloud services or in your on-premises also, if you are using the virtualization, that is called as bare metal virtualization. The virtualization which you are using in your environment, okay, bare metal virtualization, and the second one is hosted virtualization. So right now in my laptop or else in my system, I have shown you the hosted virtualization. So bare metal virtualization are used in the cloud services. Okay, now we will go very in deep into the containerization concepts and why we are going to work around with the containers in the next session. If you have any questions, you can ask me now. Yes, any
Sir,
questions?
yeah, basically, what I understood, sir, virtual machine also use the physical server space. I mean storage. Is it right?
Yes, physical server storage itself.
Okay.
Hello, am I audible?
Yes, sir. Yes, sir. Yeah. Thank you. I got it. Yeah.
Yeah, it is going to work around with the physical storage only. Any other questions? Questions? So working around with the physical storage in the sense, it is going to, we can create a folder in the physical machine and we can store the virtualization data over there. Okay. Other questions, guys? That's it. Everyone is very clear with the topic. Hello. Fantastic. So that's it from my end. We'll meet in the next session and discuss more and more topics on the Docker. So have a nice day and bye. By the way, okay, I will tell you in the next session how many days of sessions will be there, what will be the timing, what is the cost, fees cost, and everything in the next session. Okay. Have a nice day and bye.
Thank you, sir.